Hello everyone. In this section, we're going to talk about call routing. So the idea behind call routing in Cisco Unified Communication Manager, CUCM, is to receive incoming calls from outside the organization and to make outside the organization call. I mean, that means the outbound call. So basically there are two type of calls. One is inbound call, and the other one is outbound calls. So, all outbound calls, and the name suggests, it's inbound is towards the organization, and the outbound is towards the PSTN world. So if we have got the PSTN world, which has got your mobile phones, your landlines, right? The toll-free numbers, uh, and emergency numbers, special numbers, right? You have them in the PSTN world. So basically, that's the real, I would say, outside organization telephony network, right? So it's a plain switch telephony network, the real one with your cell phones, landlines, and so on, with different features. So on the left hand side, we have the organization, and the right hand side, we have got the PSTN world. And basically, we have got two type of calls: inbounds and then outbound. So, in order to understand how these things work, inbound or outbound, let's talk it a bit in details, that what exactly happens, that from outside we receive a call towards the organization, or from organization we make an outbound call to many other destination, which is outside the organization. All right, so let's say we have got our, uh, I'll use it this way, PSTN world. On the left hand side, I'll keep the PSTN world, which will have your mobile phones, which is like cellular network, uh, landlines, right? Toll-free numbers, special numbers, emergency numbers, and so on, right? Service provider could be many, right? So if we talk about them, there are many service providers. For example, we have got, let's talk about service providers here. Uh, you know, for example, Vodafone, and then you have got in the US or across the globe. In fact, Verizon is very popular. Verizon, British Telecom, right? In short, it's called BT, right? In India, we have got Tata, uh, we have got VSNL, right? So there are many service providers who provide uh, IP telephony services, right? So they are often called ITSP, IP telephony service providers. Now, these are the companies who provide mobile lines, toll-free numbers, special numbers, emergency numbers, and so on. These are the telephony, the PSTN network, right? So let me put it this way. So this guy here, uh, this section here, I would say, is the PSTN world. Now let's say we have got our organization, right? Organizations could be anything, right? So private organizations, it could be IT or non-IT. For example, we have Microsoft. Cisco itself is an organization. You have got many other IT players like Amazon, Google, right? Uh, Name the IT giants in India. We have got Wipro, TCS, and so on. HCL. So there are many IT giants which are there. I mean, these are just the example of the organizations, and these organizations would have thousands of IP phones, right? Obviously, I mean, Microsoft is not going to use Cisco phone. They are competitors to each other in IP telephony, field. They have got their own product lines. So, but just to give you an example, right? So, this could be anything else, right? So let me, uh, remove these big names, uh, and let me put it simple way. So there's a company called ABC, or anything, right? Uh, so organizations, right? These are the private organization with thousands of phones. Now, let's see how do we have the connectivity between the PSTN world and these private organizations, right? We have got a gateway in between these two parties. So I will have a intermediate device here, gateway. I'll put it a little down here, or maybe on, yeah, over here looks good. There is a gateway which connects to these service providers. So Vodafone, Verizon, British Telecom, Tata, BSNL, Comcast, right? Many service providers would connect to the gateway this organization would own, or sometimes it's the service provider itself which gives the gateway. But basically, the gateway is a device which interconnects two different type of network. On this side of world, we have got PSTN, which is running on different protocols like ISDN is very popular. Uh, and then you have got SIP recently, which is, all the ISDN existing lines are now migrating towards SIP connections. Uh, and on your organizations, your private organizations, you have got your IP network, right? So to connect the IP network, uh, which is on the organization side to ISDN or SIP line, you need a gateway, right? So this guy is the intermediate device between ISDN and IP network connection. So this is why we need a gateway to connect the two different worlds, right? So what literally happens is there's a cable, right? Ethernet cable which runs from the service provider and connects to the gateway, right? So Ethernet cable from, let's say, our service provider is British Telecom. There's an Ethernet cable coming from them and going to the gateway, and then there is an Ethernet cable, right, uh, from the gateway to the company. Okay. Let me just adjust the. Okay, looks good. So PSTN World, British Telecom has got an Ethernet cable which is going to the gateway, and that gateway is further connected to the to the company using an Ethernet cable, right? So this is a physical layering, right? Once you have got the physical connectivity up, they verify that okay, this gateway has got the Ethernet cable connected and it has got the light on it, right? And this gateway on the other side is also connected to the company, right? Company's network, and can have to and fro communication from both the sides, right? To and fro communications. So once we have this connectivity, then what happens is, these service providers sends us a call, right? There's a new call. Now, let's say it's an incoming call. Now, the service provider would send this call to the gateway. The gateway receives it. So you have to put it into the mind of the gateway. It would not do it anything on its own. So this gateway is a dumb device. In fact, in IT, everything is a dumb device. You are the brain of the IT, and you as an administrator need to control and configure everything. So you come to the gateway and you create or you configure this gateway to accept this call, right? To accept this call, Once the call is accepted, right, uh, then you got to forward the call as well, right? So I would say accept the call, and then what do you do next? You, of course, you do not want to keep the call on the gateway itself. What you want to do is you want to forward the call towards the enterprise, right? And we have got Ethernet connectivity um, with the organization, gateway, and organization, right? So we are going to forward the call towards the organization. Now, obviously, there has to be a server which needs to accept the call. There has to be a machine which needs to accept the call in the organization and then process it and then forward it to the destination, right? So in these organizations, we have got our CUCM servers, right? Uh, let's take it on the top here. I'll remove the name of the company for simplifying the conversation. So we have got the service provider. Let's put it all in one line. British Telecom. Then we have got our gateway, right? Uh, let's make it a little bigger. And then we have got our CUCM server, right? So British Telecom to gateway, and then gateway to CUCM server. So now the gateway, we talked about that it has accepted the call, uh, when it received it, and then it has forwarded the call where? Towards the call manager, right? Now, the call manager server also needs to be told that, look, when you receive a call from this gateway, right, you got to accept the call. Or you do not need to accept the call except this gateway, right? Because we do not want everything to be coming down over this UCM server. So we say, okay, fine. How do we accept the call, right? So there has to be a connectivity that we have already established through Ethernet cable, right? This is an IP connectivity. So we're going to say, okay, fine. What you do is you accept the call with the help of a trunk or that you create in between the CUCM server, or you add this gateway in the CUCM server, right? So the gateway is added, or a SIP trunk pointing towards this gateway is added, right? To accept the call, this particular gateway or the SIP trunk is added. Now the call is received in the CUCM server, right? Now what does the CUCM server does? Uh, obviously this is not the destination really. This is the call processing server, right? This is the call agent, in other words. So we have got our end devices afterwards, right? So devices. Now, what all devices do we have in our, I would say, enterprises? So we have got IP phones, which are like wired ones, and then we have got wireless phones. We have got conference phones, right? They look like alien ships. They're very big in size. I'm gonna talk about them in the picture. I'm gonna show you the different IP phones. So in fact, let me show you the IP phones here. So these are the wired and wireless types. Then you also have got your, like I talked about, wireless phones, right? So Cisco IP phone 7940, 8841, and so on, right? So um, then you have got Cisco IP phones, uh, conference IP phones, I would say. So, like I told you, they look like an alien ship or something, right, with a control panel on top of it. 7937G. It's been into the market since very long. So then you have got, recently added, soft clients like Cisco Jabber. Then you have got your Cisco's Teams. Earlier, it was known as Cisco Spark. These are some soft clients. When I say soft clients, like, these are the softwares, right? So uh, and they are not the hard phones. So these guys are the hard phones, and these guys are the soft phones. They have recently evolved. Uh, Earlier, we have Cisco IP communicator. They used to call it soft phone, Cisco soft phone. It's like a software which gets installed on your computer. Uh, so I have got Cisco Jabber over here, this guy here, and on my other PCs I have got Cisco IP communicator. Cisco Teams, Jabber, IP communicator. These are some soft phones, and IP phones, wireless phones, conference phones. These are some hard phones. Okay. Now the CUCM server, we were here that it accepts the call coming from the already added gateway or the SIP trunk from the gateway to the CUCM server, right? Now what does it do is it forwards the call towards these devices, IP phones, wireless phones, or hardware or software clients. There are other destinations as well that you know comes integrated with call manager server. For example, you could have got your voicemail servers where you simply want to transfer the call to um, the voicemail, right? Then you could have your UCCX server, which is like contact center. You do not want uh, any user to pick the call. Rather, you want the call to be routed to the contact center, or you can transfer the call outside somewhere, anywhere outside the organization further. So these two guys are an example of you know uh, soft clients, but they are the servers, and they're not the physical. They're not the devices itself. They're not the end user device. I would say they are uh, the servers which have got the capabilities to provide certain features. For example, voicemail servers are very popular across the globe. If you're not available, the caller reaches the voicemail server and answers the call on your behalf, records and gets the caller's audio recorded. Once recorded, keeps it saved in the called the destination's voicemail box. And when you come right to the office and look at your phone, you see, okay, I've got 5 voicemail servers. So, all right, I've been coming from a vacation and then I was not available. So I've got 5 different people reaching me out at my absence, in my absence. So similarly, Contact Center Express, from Cisco provides call center functionality that it provides you call queuing and distributing it to the agents and so on. Uh, so this is how you have got many destinations wherein these calls are gonna go down. So from service provider to gateway, and from gateway to the call manager server, and from the call manager server to these soft clients or servers or the hard phones. Uh, you know, this is the typical call flow. Now let's break it down further. Okay, this is an incoming call, and similarly, uh, you have got your outbound calls, right? Let me have a control here. So outbound call will be from the devices. They do not know how to route the call, so they would send the call towards this entity CUCM server, and then CUCM server will forward the call towards the gateway here, and then the gateway will forward the call to the service provider. So in between the devices and the service provider, there is a call processing server, this guy here. Then there is a gateway, which is in between the UCM server and the service provider. And then you have got the final destination for outbound call, uh, that is your IT service provider, or simply calling uh, service provider into the PSTN world. So now, since we know the components between any two call flow, let's break down, right, how these components would work. So I'm gonna remove these all text from here, and I'm gonna say Okay, we assume we already know that there is a connectivity between uh, the service provider to the gateway, and from gateway to the call manager, and the devices, right? So let's discuss about the incoming call first, how it really, works. So we have got, a mechanism called, from service provider to gateway to connect these two. We have got what you call ISDN lines, or SIP lines. SIP lines are basically, your regular IP connectivity, but they understand SIP signaling on that line. And on the gateway side, you have got, the wire comes and gets connected over here. Now, like we said, that to accept or to forward the call, the dial pair needs certain understanding, right? So we have got something called dial pair, right? For each call, we have got two legs, inbound leg and then outbound leg, right? And for each leg, we create uh, two dial pairs. For each leg, we create one dial pair. So we create for inbound dial pair, we create and an inbound dial pair. For outbound dial pair, we create an outbound dial pair. Okay, so anything coming from this guy here on the gateway will be taken care by the inbound dial pair, and anything going out from this gateway needs to be processed, needs to be configured by the outbound dial pair. So assume a situation where you created an inbound dial pair, so the calls are coming on the gateway, you see them, that they're there, but it's not forwarding to the call manager. So you wonder why, right? So basically you haven't created an outbound dial pair. So in inbound dial pair, you accept the call based on the the destination, or you accept the call based on the called number, right? Or you accept all the calls. It really depends, right, how you configure it. But for the sake of simplicity, I'm just keeping it as simple as possible. So you receive a call, and on the gateway you have got an inbound dial pair, and then the call is accepted. Once accepted, the gateway needs to forward it to the call manager. So it has got an outbound dial pair. Now, with the outbound dial pair, we have got a session target. It's like, session target is basically your IP address of the CUCM server. So it forwards the call towards the CUCM, right? The CUCM says, okay, I know this gateway. It's already added in my database. So it accepts the call. And it also needs to know the significant digits, right? In the call manager server, that how many numbers I'm going to receive from the service provider, right? So it retrieves the significant digits, let's say 4 or maybe 6 or maybe all the digits coming from the service provider as a destination number would be accepted, or it can truncate the last 4 digits or last 6 digits and so on. So it receives the call information with the called number and calling number through the gateway from the service provider. And then it has got certain configurations inside. It has got its own database, right? Uh, Dialing, it has got, dial patterns. For example, directory numbers. And these directory numbers are assigned on IP phones, wireless phones, or any of the end device, okay? Or these directory numbers can be pointed to voicemail servers, right? Similar kind of device is CTI ports, which forwards the call to not to the end device, but they are meant to forward the calls to the uh, application server, like voicemail server or UCCX server and so on. So CTI devices, CTI ports, directory numbers, right? Then you have got another thing called translation patterns. right? Uh, they are here translation patterns in the database of the call manager, is to translate, you know, the let me have it in between the call manager and the devices because that's where they belong. I would say call routing tables, right? So this is the device between call manager server and the actual physical device. Okay. Now it has got directory numbers, CTI ports, translation patterns. Then it also has got um, yeah, the directory numbers are assigned on these devices. CTI ports are meant to forward the calls to the voicemail and all. Then you also have got route patterns. So something uh, we can talk about in detail. Uh, but let's focus about the directory numbers here. So in this call routing table, we have got directory numbers which are directly assigned to these devices, CTI ports pointing towards the UC application servers, unified communication, UC stands for. So UC application servers like voicemail or contact center. Route patterns, again, these are patterns and not specific numbers. Patterns are like, you could use XXXX or exclamation. They are not fixed pretty much, and they are patterns, right? And not a specific number. Or a translation pattern where you want to convert one number into something else to hide your identity from outside world. We can take it into details later on, but for now, these are the routing table components, right? Which are there configured on the call manager server, right? So let's make it a block, right? Uh, and then you have got your devices. I'll take them further right here. Right, so then you have got these uh, devices where the actual call needs to be routed to the end user. So these end users, right, would own and pick up the calls from here, right? So the call manager receives the call and then it knows that, okay, uh, I know the significant digit actually matches a directory number, right? So for example, the call came and the extension was the significant digit we received was 1000, right? Right now, that 1000 is going to be checked under the call routing components. Would say, all right, do I have that in my database? Anything called 1000? So it would say, yes, 1000 is assigned to an IP phone, right? IP phone, IP phone A, let's say, or if the significant digit is 1200. Okay, yeah, it's going to check the call routing table again and will realize, yes, 1200 is a number assigned to a Jabber device, right? Uh, or there could be a number which, uh, let's say, 1234, which does not directly match any directory number, but definitely it matches a route pattern. A route pattern, like I talked about earlier, is like one XXX, right? So it matches the first digit. You see that this first digit is 1, so it specifically matches. Uh, and the rest of the XXX are wildcard, so it could be any digit between 0 to 9. So it says, yeah, I've got a match. I do not have a specific directory number, but I do have a match as a route pattern. Now let me see what is 1234. Now 1234 is basically, you know, uh, is a route pattern, and which needs to be routed towards the voicemail server, right? So it got a match, and then it was transferred to the voicemail server, right? With the help of route group and route place, we can talk about them later. and so on. Route pattern could be anything else as well. Translation pattern, uh, and so on. We're going to talk about route pattern, translation pattern in detail, but I want you to understand this, that the call manager receives any significant digit from the gateway side. It tries to look into its internal call routing table and then tries to forward it to the destination, right? Similarly, the IP, this is, we talked about the incoming call, right? Uh, Now we can talk about the outgoing call, originating from the devices, right? Going from devices, the an IP phone with extension 1000, let's say, made a call to outside world with a number, let's say, it dialed 91 and then dialed 10-digit number, right? 124 555 6678. So it dialed this number, let's say, and then this number is gonna go to the call manager server, because obviously the call manager doesn't the phone does not know. uh, Let me just make it a number without any decimal, so it appears as a number, not as a. Okay, so this is the number we dial. Now the call manager checked it in the call routing table. Do I have got any specific number, any directory number like this? No. Do I have got a CTI route point? Do I have a route pattern or any translation pattern? So it matched. Yes, I have got a route pattern called, let's say, 9191 dot at. So or yeah, so anything, or let's say it received 9.191.12345678910. There's a route pattern in the call manager routing table configured as 91.10 times XX, that are like the wildcards. So now it knows that, yeah, I mean, I have got this route pattern, though I do not have any specific directory number or any translation pattern which is going to translate this directory number into something else. Let me check where it's routing this call to. This route pattern tells that you're going to point to the gateway. There are components in between we're going to talk about later, which are called route group and route list. Under the route list, you have got gateways and trunks, but for now, we can directly talk about it, that the call manager receives the call with these many numbers, and then it's going to transfer the call to the gateway. The gateway received, let's say, full digits, right? And the gateway now needs to have an outbound dial pair, right? For the gateway to receive and accept the call, it needs to have a dial pair, right, which accepts this route pattern. So inbound dial pair will be matched here, right, with incoming call number, dot T, which is like anything. And then there has to be outbound dial pair, like we talked about, which says, okay, I can dial 9 and then dot and then dot 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 dot, like that, so 10 times. So this dial pair is basically gonna, let me see how many dots that I have. 1 2 3 4 5 6 7, or anything, or simply I could do is 9 dot T. That outbound dial pair is anything with right, anything which starts with 9 and then it has got any other pattern afterwards. You need to send that call towards the service provider, which is this guy here. Now, obviously, we understand that there is a connectivity in between the British telecom service provider and gateway, like ISDN or SIP, anything, right? and then the call using these two dial pairs are going to be redirected to the service provider. Now, the service provider would also have its own database and call routing table, and then they're going to transfer the call to this particular number that we dialed, that the user dialed from his IP phone. Maybe it's a landline number, so it routed right there. If it belongs to British Telecom directly, they can directly transfer the call, or if it belongs to some other service provider, then in the PSTN world, they can transfer it to other service provider, and then they can forward it to the destination. I mean, uh, these are the components and a bit in, you know, detail how the call actually flows between the devices and the service provider, right? This is very important for you because this is something, if you do not understand the call flow, you would not be able to understand and troubleshoot the actual, scenario wherein you're asked to troubleshoot, uh, an inbound call which is not working or outbound call which is not working. So you got to understand the components in between and how things work. So devices to call manager server to gateway to British Telecom and the other way around for incoming and outbound calls. All right, so I hope this session has been beneficial for you, and I'll further talk about the route patterns and translation patterns in the next chapter. Thanks for watching.